Hey everyone, so in this lesson we're going to be taking a look at the absolute value function. So we're looking at a new function and we're going to introduce some transformation rules. Okay, so first let's just review absolute value, right? So absolute value is a number's distance from 0 on a number line. Okay, so the absolute value of -5 is 5. Because -5 is 5 units from 0 on the number line. Right, so if I start at -5, we go 1, 2, 3, 4, 5 units to 0. Okay, so now we're going to take a look at what the graph of the absolute value function looks like. Oops. Okay, so we want to graph f of x equals the absolute value of x over the following interval. Okay, so for this question, I gave you guys the interval to graph. All right, so we're going to use our calculator to help us with this. So we're going to go to our calculator, we're going to go to y equals, and to get the absolute value symbol, you hit math. You're going to scroll over to where it says NUM for number, and then it's choice 1. Okay, so I'll do that one more time. You hit math, scroll over to where it says NUM, and then it's choice number 1 is absolute value. Okay, so we want the absolute value of x. So now we're going to hit second graph to access our table, and we want to copy the values from -3 to 3. So 3, 2, 1, 0, 1, 2, 3. Okay, so right away you'll notice, similar to when we graph quadratics, when we graph parabolas, all right, the absolute value function does have a turning point, right? The y values repeat around 0, 0. Okay, so for this graph, the vertex is going to be 0, 0. All right, so let's take a look at what the graph looks like. So we got -3, 3. -2, 2, -1, 1, 0, 0 is our turning point or our vertex, 1, 1, 2, 2, and 3, 3. All right, so since we were told to graph a specified interval, I'm not going to include arrows. All right, so this is the function for the absolute value of x. All right, so you notice it kind of takes on a V shape. All right, so domain, in this case, our domain was given to us, right? Remember, domain is your x values. So they went from -3 to 3. And our range is our y values, okay? So you notice the y values start at 0 and go up to 3. Okay, and if we go back to our calculator for a second, and we hit graph, all right, you'll see that the absolute value graph kind of takes on that V shape. All right, so now let's take a look at another example. Okay, so in this second example, we want to graph y equals the absolute value of x plus 2. All right, so I'm going to go to my calculator. And I want y equals the absolute value of x, which I already have in here. So now I'm just going to hit plus 2. All right, now here they didn't give us a specified interval. So we're going to look in the table to see where the y values repeat. Okay, so you'll notice right here we got 5 and 5, 4 and 4, 3 and 3. So 0, 2 is my turning point. All right, so I typically go 3 values below the turning point and 3 values above the turning point. So a good interval to use here would be from -3 to 3. Okay, so I'm going to copy the table from -3 to 3. All right, so then those corresponding y values were 5, 4, 3, 2, and then 3, 4, 5. Okay, so we're going to graph. All right, so 0, 2 is our vertex or our turning point. All right, and here this time I am going to include arrows because they didn't give us a specified interval, right? We came up with the interval by ourselves. So this is y equals the absolute value of x plus 2. Okay, so now they want the domain and the range. So in this case, domain is going to be all real numbers because my graph goes all the way to the left and all the way to the right. All right, my range, well, the smallest y value in the table is 2, and the minimum y value graphed is 2. So my range is going to be all values where y is greater than or equal to 2. All right, so now in this next part is where we talk about the transformation. So it says compare the graphs of y equals the absolute value of x and y equals the absolute value of x plus 2. So if I go back to my first graph, here's y equals the absolute value of x. So my vertex was at 0, 0. When I look at y equals the absolute value of x plus 2, my vertex is at 0, 2. So what happened was all the points shifted up 2 units. All right, so when I add 2 at the end of the equation, the graph shifted up 2 units. All right, and this is something we can also verify with the calculator again. Okay, so I'm going to go back to y equals, and in y1, I'm just going to type in the absolute value of x. So I'm going to delete the plus 2. Okay, so y1 is the absolute value of x. y2, I'm going to type in the absolute value of x plus 2. Okay, so when I graph, y equals the absolute value of x is going to be in blue. Y equals the absolute value of x plus 2 is going to be in red. So watch what happens when we hit graph. All right, so again, you'll notice all that happens is that when I add 2, every single point shifts up 2 units on the graph. Okay? So now on your paper, it says what will happen if we graph y equals the absolute value of x minus 2? Well, we can look at that on our calculator. So in y3, I'm going to graph the absolute value of x minus 2. All right, and you guys can probably guess what's going to happen. All right, so when I subtract 2, you'll notice my vertex moves down 2 units. All right, so when we subtract 2, the graph is going to shift down 2 units. So let's go to the next example. So in the next one, we want to graph g of x equals the absolute value of the quantity x minus 3. All right, so you'll notice in this example, the minus 3 is inside of the absolute value bars, or we say sometimes that's inside the function's argument. Okay, so we're going to go back to our calculator. All right, I'm going to go to y equals and clear everything I have in here. And now I'm going to type in my new equation. So it's the absolute value y equals, try that one more time, absolute value of x minus 3. Okay, and again, make sure the minus 3 is inside of the absolute value symbols. So now we're going to hit second graph, and we're going to look for where our y values repeat. Okay, so it looks like we have some repetition right here, right? So we got 3 and 3, 2 and 2, 1 and 1. So it looks like our turning point or our vertex is 3, 0. So I'm going to go 3 values below the turning point and 3 values above. So for this example, we're going to graph from 0 to 6. All right, so the corresponding y values were 3, 2, 1, 0, and then 1, 2, 3. Okay, so we got 0, 3, 1, 2, 2, 1, 3, 0 is our turning point, 4, 1, 5, 2, and 6, 3. So that's the graph for g of x equals the absolute value of the quantity x minus 3. All right, so here my domain, again, is going to be all real numbers because my graph goes all the way to the left and all the way to the right. And then range, well, the minimum y value on the graph and in the table is 0. So my range is y is greater than or equal to 0.